Okay, so I wanted to start today, and welcome to LPN 100 Fundamentals. We're at Bayshore campus, and so I wanted to start today with some review of some terms and stuff like that. So if we're talking about our ethical and moral obligations, for example, what does veracity mean? Veracity. We talked about these terms last week. I'm trying to get you to dust off your brain. Any thoughts? What about fidelity?
Keeping your word.
Fidelity is keeping your word. So what would be an example for that?
Say you're going to do something and make sure you do it.
Saying you're going to do something and actually doing it, correct? I'll be back in 20 minutes when you can have your pain medicine. So then we make sure we go back in 20 minutes because we're keeping our promise. By doing that, what are we doing for our patient? Establishing rapport and having a good relationship, right? And a good relationship is the core to what? To taking care of our patients, right? How come it's so important?
Because maybe if the client don't trust you, you're not going to have like a good outcome towards your goal or care plan.
Exactly. The client doesn't trust us. They may not tell us everything that they need, right? So we can't help them fully. So, veracity, anybody?
Telling the truth, honesty.
Telling the truth? What about non-malfeasance? Thoughts? That's a $2 word, huh?
You said non?
Non-malfeasance.
Not causing harm. Not on purpose.
Not causing harm?
Not on purpose.
So there was an example we talked about last week where the nurse chose the bigger needle because of, for that patient. Pardon?
Malfeasance is being malicious or deceitful, lying.
Yeah.
And veracity,
And we want non-malfeasance, so we're not that. Veracity,
veracity is the opposite of that, which is being honest. Or
telling the truth. And then what about beneficence?
kindness,
And what else?
benefit,
Pardon?
benefit.
What we do is to benefit, right? We do that to benefit our patients.
Can you say that again?
Beneficence. B-E-N-E. Okay, and remember that at noon, you're having a test-taking seminar, right? Over the lunch hour? Just give me 1 minute, I have to pull up my stuff. So we're going to talk a little bit about fluids and electrolytes today. And how much fluid do we typically have in our body?
5 to 7.
What's that?
5 to 7 milliliters.
Not mils.
Liters. Oh, liters.
400,000.
Oh.
400,000.
No, 400,000. That's funny. What does this fluid do for us?
Regulates our body. Fluid.
helps keep things in regulation, right? So you guys have had information on osmosis, diffusion, correct? In your science course? Oh, there we go. So what is osmosis and diffusion?
Osmosis is the balance of what's the word I'm looking for?
Pardon?
Osmosis is the balancing
Of what?
of your electrolyte hormones. Gradients, you think?
Pardon?
The gradients.
There are gradients involved. So when we're talking about, let me pull this down. Osmosis, if you look, I think it's 25.2 in your book. There's a good picture there. This will take a second here.
You talking about our calculation book?
No, your class book. Your textbook. I think table 25.2, it's pretty early on. Okay. So when we talk about fluids and electrolytes, everything is a balance. We've talked in the past about homeostasis, correct? And you've probably heard that in other science courses. What does homeostasis mean?
The balance of your internal and external.
It's like a steady state, right? The body wants to be in a steady state. That's just natural. And so let me turn off one of these. And so, is that better? Okay. So when we talk about electrolytes, they're dissolved in our fluids, right? They're called electro because they have charges when they get dissolved. Some are positive, some are negative. Cations, positive charge. Anions, negative charge. Okay? Ideally, our pH is between what in our blood?
Maybe 0 and 4.35.
Pardon?
Is it 4.35 like the?
No, 7
You said
to 7.45.
we're normal.
Yeah, yeah.
Yeah, like 7.45.
735 to 745. So this is showing it neutral. If our pH goes down, that's acidosis, right? And if our pH goes up, alkalosis, right? Right. Okay. So obviously fluids are very important. So this is kind of like Goldilocks, right? This person has too much fluid, think fluid overload, correct? This person has just the right amount. And this one has too little. So with this, you're going to see symptoms. If you have too much fluid on, what might you see?
Edema.
Swelling, edema. What else might you see?
High blood pressure.
Higher pressures. Other things? Could be going into heart failure. What else? Think about another organ. How do we get fluid off our cell? How do we get kidneys? So kidneys could be having trouble with functioning. And it could be part because of heart failure. Could be a pre-existing kidney disease, right? So this is what electrolytes do. They conduct electricity. They're minerals in our bodies. They do you have any idea what some names of these would be? Electrolytes? Pardon?
You got some examples on board. Potassium, sodium, calcium.
Sodium, potassium, yeah, exactly. Magnesium, totally. Now we can get these also from food, obviously. A lot of fruit and stuff is high in potassium, for example. What would be high in calcium, food-wise? Dairy products, yogurt. Okay. So, part of what happens with electrolytes is their job is to balance our pH, to keep the blood level between 7.35 and 7.45. Again, if it goes to 7.20, what does that tell us? Acidosis. If it goes to 7.60, the normal is 7.35 to 7.45. So if it goes to 7.6, that's higher. Higher means alkalosis, and we'll talk about how this all happens. They also move nutrients into the body cells, and they're very important for muscle and nerve function. You can see signs and symptoms of hyper or hypo types of electrolytes based on what the patient is displaying. So let's move forward here. Questions at all? So we have body fluids, obviously, right? And so they're kept in various compartments. And that is supposed to be balanced as well. So if the body fluids are intracellular, they're within the cell. The water in each cell. Pardon? Was there a question? No? Okay. So the water in the cell, each cell holds onto water. Extracellular is outside. So intra always means in, right? Extra is outside. So extracellular, we have fluid in our, what? Interstitial spaces. That's fluid that the cells are floating in, so to speak. Intravascular is the amount of the fluids in our vessels in our bloodstream. And then we have transcellular, which is things like aqueous humor in your eyes, gastric juices, cerebral spinal fluid, those type of things. Question?
Wouldn't intravascular and
Interstitial?
wouldn't that be the same thing?
No.
Because it's fluid between blood vessels and cells.
No, this is intravascular is actually in the vessel. Interstitial is around them.
Oh.
Okay? So intravascular inside the vessel. Question?
He was waiting for you to change it.
Yeah. Set? So extracellular, remember that's interstitial and stuff like that, right? That's not in the cell. That's a third of the total body water. What does it do? Transports nutrients. Don't forget oxygen has to get transported, right? When oxygen gets metabolized, picked up by the lungs and then used in the cells, what comes back? CO2, right? How do we get rid of carbon dioxide typically?
Through the kidney.
Breathing though first. Yes, breathing out. So all of this is regulated by kidney, metabolic, and neurologic factors. Extracellular fluid is high in sodium. Pardon?
We going over neurologic.
I'm sorry, I can't hear.
No, I said we going over this in lab.
Oh, good. Excellent. If we're talking about intravascular, again, that's within the cells, plasma and fluid and stuff. Has a lot of protein in it and electrolytes that help maintain the fluid within those cells and our fluid balance within the cells. So different electrolytes have different jobs. Okay? Oh, and here's examples of the transcellular fluids. Lymphatic system. What's a lymph system? For immunity, and it kind of runs throughout the body, right? We have lymph nodes and there's lymph vascular, right? What's synovial? Any ideas?
That's like the fluid in your joints.
In your joints. We all have some fluid in our synovial joints. Pericardial fluids. Fluid around the heart. We have to have some. How come? What is the heart contained in? It's contained in a sac, right? So there's fluid, so there's not that friction when the heart beats. Gastrointestinal secretions are things like gastric acids, bile. So that's all the transcellular areas. So when fluid moves, there's diffusion. What is that 25-2, that table? I meant to bring it up. You're right there. You just turned your page. Go back one. Right here. What page is that? 448. 448 is showing us how fluids and molecules move in the picture. So, when we talk about fluid movement, that would be considered osmosis. How come? And when fluids or solids are moving back and forth, are they going through anything? What's it called? The cell or vessel. Semi-permeable membrane. Right? And that's the picture, has that little, that's supposed to be the semi-permeable membrane, that little line down the beakers. And if you notice, in A, we have what process happening? Look at the pictures there. Is that diffusion? Do we agree? And so diffusion is the movement of the electrolytes and proteins and whatever across a semi-permeable membrane. One side has more, one side has less. They move over to even out. The side with more moves some of those substances over to the side with less. And then I think it's a third picture, they're pretty even, right? fourth, whichever. And then if you look at B, that's osmosis. Do you see how in the first beaker the fluid is at one level? In the second beaker, notice the fluid is at a different level. Fluid has moved across that semi-permeable membrane to even things out. And they're not necessarily, and why is it doing that? To even out concentrations. Does that make sense? Okay. We'll talk a little bit about that slide in a little bit. So, I put this in red. Substances are moving in diffusion. Think of the dots rearranging themselves across a semi-permeable membrane. So everything wants to be equal, homeostasis, steady state. These are the type of substances that move with diffusion. We talk about osmosis. Oh, and by the way, osmosis and diffusion are passive transport. We'll talk about active transport shortly. So osmosis is movement of the liquid across the membrane, like picture B on that page. What page was that? 448? Okay. So they're trying to get concentrations equal with osmosis through moving fluid. Do you guys know what semi-permeable means?
Yeah, it's like, yeah, it only picks certain cells to bring through.
Certain things, only certain things can pass through. Some molecules are too large. Sometimes that kind of a thing. Questions? Okay. So if you have too many molecules on one side of a membrane, how is that getting fixed?
Diffusion.
Diffusion, right? The molecules are moving. Again, to be steady, think balance, balance, balance. That's what the body wants, is balance. Now then we have filtration. That picture is on the same page. Fluid gets pushed out through the semi-permeable membrane. And any electrolytes that need to be moved. How does this happen? It's something called hydrostatic pressure. That is the pressure on the vessels from the heartbeat. The pressure exerted as the blood is moving, based on the strength of the heartbeat. Okay? Makes fluid push against the walls and then things go out. Again, for what reason? evenness, right? Everything wants to be even. Okay, let's take a few minutes here and then we'll continue.